In this particular question, we're asked to find three different lines, equations in both vector form and parametric form, and the lines themselves are given initially in symmetric form. So, starting with the first one, we have x plus 1 over 2 equals y minus 8 over negative 3 equals z over 6. Well, a point that this line goes through is negative 1, positive 8, 0. And the direction vector is 2, negative 3, 6. So here's our vector equation. And then converting that to symmetric or to parametric equations form is pretty straightforward. X is negative 1 plus 2 times t. Y is 8 minus 3t. And z is 0 plus 6t. Okay, moving to the second equation in this situation, we have the original equation being x plus 4 over 2 equaling z minus 7 with a y value of 4. Well, as soon as you see a comma and a value off on its own like this, that means it's being done because the value is constant, which means that the component of the direction vector will be 0. And we have to put it off to the side because in symmetric equation form, that would be in the denominator, and we can't say y minus 4 over 0. That's an invalid expression. So we have to simply say y equals 4. What that means is that the y value will always be 4, and the direction vector component for y is 0. So we get negative 4, 4, 7 as our point, and 2, 0, denominator of 1, as our direction vector. And that's what happens. Negative 4, 4, 7 is our point, and 2, 0, 1 is our direction vector. And using this, it's pretty straightforward to get the parametric equations form. Negative 4 plus 2t is our x, 4 plus 0t, or just 4, is our y, and 7 plus 1t, or 7 plus t, is our z. And finally, in this one, if I can get it, this is a little bit tricky. We have x plus 2 over a half equals y minus 3 over a sixth equals z plus 1 over negative 1/5. Well, on first glance, we say pretty straightforward, negative 2, 3, negative 1, plus t times a half, a sixth, negative a fifth. And that is a perfectly valid answer. However, we don't usually like to have fractions in our direction vector. We like to have it in simplest form, but with integers where possible. So what we're going to do is figure out the lowest common denominator of 2, 6, and 5, and that would be 30. Multiplying each of these by 30 gives us 15, 5, and negative 6. So we still have negative 2, 3, negative 1 as our position vector. We don't multiply that by anything because it's a location, not a direction. And then we have 15, 5, negative 6 as our direction vector. And so our parametric equations can be given as x equals negative 2 plus 15t, y equals 3 plus 5t, and z equals negative 1 minus 6t, where t is an element of the reals.